All right, guys, we're starting on worksheet 10 with a little review, warm-up of what we did yesterday. Part of the issue is if you went home and tried to do your homework, you may have been confused unless you looked at the board, because I forgot to tell you that the page is 566, not 556. Hopefully, if you check the section, you got the right page. Otherwise, it is correct on the board in two different places, but on the worksheet, it's a typo, and I'd already run them off before I found it. So we're going to review this anyway. We didn't do all these yesterday for practice, so it's good practice to go back and look at them. Remember, we realized that they are all R equals ED over, and that it's 1 plus or minus, either sine or cosine. Oh, E in front, sorry. And a theta. Now, the cosine ones had a directrix of x equals. The sine ones had a directrix of y equals. If it had a plus down here, then the d was positive. If it had a minus down here, then the d had a minus in front of it. D itself, the number E and D are always positive, it says at the top up here. So the formula has a plus if the D is, the D is always positive. The directrix, if this is a plus, the directrix is y equals positive D. If this is a minus, the directrix is y equals negative D. Sorry. All right, just to try to summarize again. I'm not going to take your reference sheet away from you. Unless you're going to be an electrical engineer or a physicist, you're probably not going to do most of this stuff. Especially what we're doing today, because we're doing with imaginary numbers and graphing. Okay. All right, let's try one or two of these. I don't know. Let's do number 4. 1/4 or divide by 4, yes, because we need this 4 to be a 1. Okay? So if we divide everything by 4 or multiply by 1/4, same thing, we'll get 3/4 over 1 minus 2/4, which is 1/2. So what is that telling us? E is 1/2, which makes it what shape? Okay. Which you could find by graphing it, but you also should know the eccentricity. By the way, Jacob realized I had a problem with this, so I'm just going to give you guys a hint. If you don't make your window wide enough and it goes off the edge, what can an ellipse look like? A parabola, yeah. I had one on my homework that I drew a parabola, and I had the eccentricity right, but my window was such that it was all cut off. The rest of the ellipse was cut off, and so I drew a parabola. Jacob's like, Miss Hoffbar? I'm like, oh, he always finds my mistakes. All right, we got to find the equation of the directrix. E times D is 3/4, and E is 1/2. How do we get rid of that? We multiply by 2. So we either get 6/4, which reduces to 3/2, or we could just simplify right there and get 3/2. So we have D is 3/2. That's not an equation of the directrix. What do we have to write? Perfect. X equals, because it's a cosine and it has negative. And you can use your sheet for that, right? Everybody know what I'm talking about? If you looked on this sheet here, it clearly said when it says 1 minus cosine, that this is x equals negative D. So we weren't just making that up. I was going to say pulling it out of anywhere, but okay. We'll amuse Brenton if he listens to this video, right? Okay. Let's try number 9. These were the ones where they gave us a bunch of information. I think these are super easy because if I know this, is it going to have a cosine or a sine?
Cosine.
It's got an x, so it's going to have a cosine. if it's a positive 3/2 on the bottom is going to be 1 plus cosine theta. Oh, I forgot something. The E goes in there, and they already told us the E was 1/3. And on the top goes E times D. Well, what's D? Yeah, this is D right there. So 1/3 times 3/2 is 1/2. Okay, so that's not a pretty one. Anybody know what we could do to make that look better? We could change it to a 0.5. What would you have to multiply through to get rid of all the fractions? 6, the common denominator of 6. So you'd have r equals 3 over 6 plus 2 cosine theta. I don't care. It's easier to type in the calculator this way. But I would accept either answer. All right, what shape should it be because the eccentricity was 1/3? An ellipse. I seem to remember this is a teeny tiny little ellipse. And you have to remember the parentheses, guys, around the denominator. I had some people telling me they're not getting the right graphs last period. Yes, because they didn't put parentheses around the denominator. It is seriously like this big. And the directrix is out here at 3/2, which would be a vertical line through. Okay. Vertical, clearly mine is. How do you? Well, and it's hard with the circles there. It just makes it worse, doesn't it? All right. These 3 questions, last of our warm-up today, all are about the same equation. Okay. What did they try to trick us with? They flipped this. So the denominator, we're used to seeing this. What else did they do? The first question asks for the eccentricity, and I guarantee if this is a multiple choice question on the quiz, 8 will be one of the choices. And someone will pick it. We have to divide by 16. So we get 3 over 1 plus 1/2 cosine theta. So what can you tell me? E is 1/2. That's the first answer. And that makes it an ellipse, which is actually number 12. Jenner's got a 2 and 1. Last thing we need is the equation of the directrix. So we need to find D. E times D equals 3, the numerator, right? And the E is 1/2. So we get D is 6, and it is a cosine equation, so that tells us it's an x equals. The quiz is next Wednesday. We're going to learn new material on sequences tomorrow and Monday. Tuesday we will review for this quiz. I have a worksheet for you to review. Wednesday will be the homework check because it's the same day as the quiz. Tuesday and Wednesday next week we have to meet in another classroom. You guys should all be here, but we're displaced because there's some Algebra 2 kids taking their park test in here. So we're going to meet in a social studies room, and I'll have to use the whiteboard if you have questions. No big deal. But we will be reviewing and taking a quiz those 2 days. Then on Thursday next week, I'm going to miss almost all of you because you're going to be bubbling for the ACT that day. Okay? The rest of us who are here will work on the sequence stuff that we're going to do Monday, Tuesday. Everybody else will have their own personal work day when they get home from bubbling the ACT. All right. We have one last new thing to learn before that quiz next week. It is this lesson On complex numbers and de Moivre's theorem, we're not going to do that part of it. I probably would have skipped this lesson altogether, except the part we are going to do is really easy, and it's actually a Common Core standard. Okay? There's a Common Core standard that says be able to graph a complex number and find its absolute value. And those are truly really easy concepts. It is the only non-multiple choice question on the quiz next week. Super easy. Okay. Before I forget to talk about this, the applications of this section, because it's going to seem like really out there weird stuff. Electrical engineers, if you ever have to take Calc 3, you'll do some of this. And some physics applications of this stuff. Okay? We looked it up because we were curious earlier today. If you look in the book, there's a whole paragraph about how electrical engineers use this in regards to impedance and resistance and all this kind of stuff that I didn't even know what those words meant. But I did take physics once a long time ago. But all right, guys. All this is talking about is graphing a complex number. What they do is they take the x-axis and rename it the real axis, and the y-axis is renamed the imaginary axis. So a complex number like 2 plus 3i would be 2 units to the right and 3 units up. Think you can handle that on the quiz next week? I think on the quiz I even labeled them R and I, so you won't get confused. Okay, this whole graphing system is called a complex plane, or it's called an Argonne plane. I don't know if I'd ever even heard that before I read the notes. The other thing besides graphing these, and you could have like, something really tricky like just -6i. Where would that go? Yes, across 0 and down 6, you'd have a -6i. Okay? Okay. All right, but we have to do the absolute value of that complex number. Does anybody remember what absolute value meant? Like on a number, it has to do with distance. Absolute value is? It's always a positive number. Okay. Distance from 0. Yes, it is the distance from 0. Well, guess what? On a complex number system, or a complex, it's the distance from the origin. How are we going to find the distance from the origin? Pythagorean theorem. In the past, we called that R. Do you feel like we've recycled this x squared plus y squared equals r squared and x equals r cosine theta, y equals r sine theta over and over and over for the last 3 weeks, huh? Good. All right. So the absolute value of this number is 2 squared plus 3 squared square rooted, or square root of 13. All right. So let's go directly here. There's a beautiful slide in case you wanted to know. The absolute value is this. Okay. There it's real, imaginary. So on your homework, label them R and I, not X and Y. All right, I'm skipping all the way down to these because I think we can handle it. How do you graph 5 plus 2i? Right 5 on the real axis and up 2 on the imaginary axis. That is 5 plus 2i. In the book, a lot of times they will say z equals, I don't really know where that comes from, but sometimes they'll label that z, and then they'll say find the absolute value, or you could write it like we did earlier, 5 plus 2i, the absolute value, because it says to do both. Find the absolute value. How do you find the absolute value again? It's the distance from the origin. So if this is 5 and this is 2, square root of 29. All right, can you guys try 1b? Oh, I didn't do one with a negative. Left 3, up 4. Absolute value is negative 3 squared plus 4 squared is 25. Square root is 5.
Why do they take the absolute value of it if you're squaring it anyway?
We're not actually taking an absolute value. It's called the absolute value of that point. Yeah, that's kind of weird. You're absolutely right. All right. I need to go back and talk about a vocabulary word that is not on these sheets. These are in the form that is called rectangular form of a complex number. When we learned it, we learned a plus bi is a complex number. Do you remember that? A plus bi form, the directions would always say. Okay, that's the rectangular form. We're now going to talk about what's called polar form of a complex number. Okay, we don't really understand polar stuff, and now we're going to do complex with polar, just so that we're totally confused, okay? It's really, the form of it isn't hard. It's just like, what are we really talking about is kind of a far grasp for me. But what we're going to do is we're going to take this a, which we used to call x, right? And we're going to say a is our cosine theta. This b, which we used to call y, our sine theta. All right, then what we have to do is we find this r value here, and we say times the cosine and r times the sine theta, and it had an I. We factor out the r, and we get this form. It's called the polar form of a complex number. It's this mess. Instead of writing r cosine theta plus I r sine theta, they factor out the r. That's it. Let's try one. Oh, wait. Let me wow you with some vocabulary again. The r, when we're doing this particular thing with complex number, the r is actually called the modulus. And the theta is called the argument. Again, I would have never known that if I didn't read, because I don't remember that, and I don't think it's that important. Look, it is in your notes, though. That word is nowhere on the quiz, I promise. Let me answer that question. No, I'm not going to give you an equation. The 4 things you need to know, we talked about yesterday. Pythagorean theorem, inverse tangent, r cosine theta equals x, r sine theta equals y. It's all the same stuff. If it would concern me, Ben, if you had to do these, if I said change from rectangular to polar complex form, because then I think you'd go, I don't know what that means. But because it's multiple choice, I think you'll be fine, because all the choices will be in the right form. You just have to pick which is the right choice. Does that make sense? So, and the reason I'm doing that is because this is not something you need to know forever and ever and ever, but you've seen it once. If you ever have to learn it again, hopefully it'll look vaguely familiar. So I'm giving you multiple choices because I think you don't get all caught up in the vocabulary and do the wrong thing otherwise. This one says express. Did we not have to graph anymore? Did we already graph? I kind of got confused. You have not graphed yet? Okay, I got confused. Sorry. All right. This says complex number in polar form. The polar form means, when I see that, I think r theta, so that's my hint that I need something with an r and a theta. But this is saying a or x is 1, and y or b is -1, right? If we graphed this, we would go right 1 and down 1. Everybody okay? Real, imaginary. Now, we want to do as many of these as we can in exact form. So whip out your unit circle if you don't have it. Or somebody just tell me they remember their geometry. If we have sides of 1 and 1, so 45, 45, 90. Square root of 2. So r is square root of 2, and the angle is like a -45, right? We have to do all these in radians because somebody decided that these have to be in radians. So what's that? Negative pi over 4 would work. I would be okay with that. They would probably use 7 pi over 4. Is that right? In that quadrant? Everybody okay? Okay. So we have to write this as r goes out in front, and then cosine of the angle plus I times the sine of the angle. Now, like I said, that's a weird form that would be uncomfortable if I just said you have to memorize this or come up with it. But if all the choices looked like that, could you pick out the one that had the right r and theta values? Okay. Let's try number 3. Number 3, is this going to be one we can use our unit circle for? Over 3 and up 2. There's some 2's and 3's on my unit circle. But are there real 3's and real 2's, or there's some square root stuff, right? This is square root of 13. So I have square root of 13, and I have cosine of some angle plus I times the sine of some angle. I don't think it's on my unit circle. What do I have to do? Sam, what'd you say? Inverse tangent of 2/3. It's all the same stuff we've been doing forever. Inverse tangent. In what mode did I say earlier? I'm sorry to say radians. They want all these in radians. Now, you do have to be super careful about the quadrants. If you're in the wrong quadrant, add pi. Because tangent has a period of pi, yes? So if it's positive and it's in the wrong quadrant, it needs to move exactly halfway around the circle. Add pi. If it's negative and it's in the wrong quadrant, add pi. Okay. Let's try this number 4. Oh, that's a nice vertical line. -1 square root of 3. Okay, when I do r, I square root of 3, I get 3. I square -1, I get 1. 3 plus 1 is 4. The square root of 4 is 2. Does that look like something on our unit circle? Anybody know their special right triangles? What's across from the square root of 3? You have leg square roots of 3, and 2 times the short leg for the hypotenuse. It is a 60 degree. Anybody know what that is in radians then? We want this angle actually. Okay. If you look, guys, do you find one that says I went over this and up this? That's the point we're looking for, right? Because they just, if you divide everything by 2. All right, I would have taken a decimal answer if you got confused and gave me a decimal answer here. But what would this look like in exact form? Of 2 pi over 3, just because this is all a function, it's not actually multiplication. Go ahead.
Plus I sine.
Good job. Okay. And again, if you had given me a decimal instead of 2 pi over 3, I'll live with it. What if on the quiz you get a decimal and there's exact answers on the choices? No. Type all the choices in your calculator, see which one matches the answer you got, right? Okay. All we got to do, guys, is go the other way and we're done. Let's go the other way. What the form said, r cosine theta plus I sine theta. I wonder what r is. And I wonder what theta is. So can we plot that? Be careful, the radius, the graph paper counts by 2's, right? So 4 pi over 6 is right here. Okay, yeah, that was really hard. Okay. The other thing we have to do is change it to rectangular form. Rectangular form of a complex number is a plus bi. Or x plus yi, if that feels better. So what are we going to do? Look, we're just going to distribute 4 cosine theta plus... I know, last time I'm like, okay, if r is this and theta is this, we have r cosine theta. Well, it's already written right there for us. So we do 4 times, what is the cosine at pi over 6, guys? Okay. And back here we have 4 sine pi over 6. And what is the sine at pi over 6? Simplifies to? Okay, that's rectangular form. So for number 6, it is a little weird. 5 pi over 4 is in which quadrant? Because it's not labeled on my graph paper. Third quadrant, right out here. 4 square roots of 2. Anybody got a decimal for us? Jacob, did you just type it in? Half the class already typed it in. Okay. So it's close to 6, right? So I'm going to go out to that ring almost. I'm going to use the famous Hofbauer big dot theorem to go it's somewhere in that general area. And then what am I going to do? And change them, right, to values so I can find the a and the b. So 4 square roots of 2 times, what's the cosine of 5 pi over 4? Negative square root of 2 over 2. And the sine is also negative square root of 2 over 2. Okay. We could type that all in the calculator. It'd be a lot of typing. Square root of 2 times square root of 2 is 2. Divided by 2 is 1. So I just get 4, but it has a what? Negative. Back here, same thing. Hey, just because I wear glasses, don't call me names. I have one eye. All right. What about this? 5 pi over 3 is way over here. Out 6, 2, 4, 6. Cosine of 5 pi over 3 on your unit circle? Is it? Isn't it 1/2? Yeah. And the sine is square root of 3 over 2, right? Yeah. And the sine is negative, but the cosine is positive? Yes? Okay. So we have 6 and 6 here, and there's an I. So what do we end up with? Oh, it's minus, not plus in the middle. Minus 3 square roots of 3. Everybody okay there? This was times. I should put some parentheses probably. And there's an I. A lot of times I would write that 3 minus 3i square roots of 3. It doesn't matter. The I does not belong underneath the radical though, right? Okay. So either one is fine. Just try to make it clear. I'm not going to worry about it because it's going to be a multiple choice question. Okay. Again, the only question on next week's quiz that is required that is not multiple choice is this question. graph it and find its absolute value. And I think, honestly, that I labeled R and I on the graph. All right. There is also a bonus question on the quiz, like the plane is flying this, and if the wind is blowing from this direction with this velocity, what is the ground speed and direction of the plane? But that's a bonus question, so. Yes, exactly. Where do you bury the survivor? It's one question. I hope I'm not, no, I'm just adding. Add number 16 to the assignment. Also, please notice that as many of them as you can, use your unit circle and give exact answers, okay? And when it asks for polar complex form, it wants radians. Yes, Faisal. Does 22-23 say to graph, but and there's no graph paper, circle graph paper? I'm not going to worry about it. Okay? Shall we go with that?